Hi, scientists. I am going to read you a book about mass. And mass is an interesting word. It's a tricky vocabulary word, too, when it comes to science, because a lot of time we think about mass as weight, and those are very different. So, hopefully, after we read this book, you'll have a better understanding about what mass is and the difference between mass and weight. It's great for scientists to use the term mass and to use mass to help us understand so many things in our environment. Mass at work. About mass. Have you ever watched a train slow to a stop or hit a baseball? This is mass at work. Mass measures how much matter an object has. A cow has a lot of mass. A feather has less mass. Mass is the same everywhere. What's the difference between mass and weight? Weight measures the pull of gravity on an object. So weight we have here on Earth because gravity is pulling us to Earth. The United States measures weight in pounds. We'll say how many pounds we are or something else is. Most other countries in the world measure in kilograms. You'll learn a lot about kilograms at the end of elementary school and middle school and high school. Tyson uses a scale. He weighs himself. He weighs 50 pounds. That is 23 kilograms. Weight changes away from Earth. The moon has less gravity. An astronaut weighs less on the moon. The astronaut's mass stays the same. So the mass is staying the same. It's how much matter he has, not his weight, not how much the gravity's pulling down. So no matter where you go, mass always stays the same, even if you go to the moon. Mass is not the same as size. Nate's balloon is big, but it has a little bit of mass. Gia's rocks are smaller, but they have more mass. Many scientists have studied mass. Isaac Newton studied physics. He looked at how mass changes motion. We're going to learn about him this year too. Objects with more mass are harder to stop. A bus has a lot of mass. A bike has less mass. The bike can stop more easily. Or if you have two toy cars and one has more mass and it is bigger, and you can tell if one hits your hand, it might hit harder than the little one, which will just hit a little bit softer. Think about it. Look around you. Where else is mass at work? And how do you use it? Seesaws are a great example. Sometimes there are two objects that have different mass on either end. Usually, on Earth, when something has more mass, it goes down faster. Great job. This is a nonfiction book, so it has a glossary. The glossary tells us about the vocabulary words and gives us the definition of them, which is great to have in nonfiction books. So there are a couple, but I want to point out matter. So matter is anything that has weight and takes up space. So is Miss Lodato matter? Yes, I matter. Is a balloon matter? Yes, it's matter. Is my pencil matter? Yes, because it has weight and it takes up space. What about a piece of sand? Is that matter? It is, even though it's small, it has a weight and it takes up space. So there almost everything that we can see or touch is matter. Some things we can't see or touch. Alrighty. I am so glad that we were able to read more about mass. And we know that mass and matter are close together. So the more matter something has, the more mass it has. Thanks so much, scientists.